Okay, so the final part of the first semester is chapters 8 and 9. These are chapters that you have not been tested on yet. So they're going to have the most questions on the final exam. There are 14 questions out of 40 on this section right here, and they're mostly on um, chemical names and formulas. So this is where we learn how to write the chemical names and write out the chemical formulas. Okay, so this is chapters 8 and 9. Actually, it's all of chapter 8 and only the first two sections of chapter 9. And that's as far as we got. All right, so let's take a look at what was covered in this section of the class. Um, we talked about types of chemical bonds. And to summarize, because one of them was in chapter 8, the other was in chapter 9, there are ionic bonds and covalent bonds. And you should know kind of the difference between the two, how the two are formed. Remember that ionic bonds are found in ionic compounds, and you can identify an ionic compound if the formula or name begins with a metal and then a nonmetal. So it's a metal and a nonmetal. The exception to that is ammonium ion, or NH4 is the one polyatomic ion that has a positive charge on it. So sometimes our ionic compounds have an ammonium to begin with, and their formula begins with NH4 or the word ammonium. So you can identify them. So it's either a metal or ammonium um, that the formula begins with if you have an ionic compound. Molecular compounds are held together by covalent bonds. Remember, covalent bonds are the ones where the electrons are being shared. The valence electrons are being shared between two atoms, and that holds the two atoms together. So molecular compounds are made up of two or more nonmetals. If they're all nonmetals in your formula and they don't start with NH4, then you have a molecular compound. Okay, so you should be able to identify them, and you should know how to find a metal and a nonmetal on the periodic table. Okay. If you have an ionic compound, you should be able to write a formula. You should be able to know how to come up with the ions for each element on the periodic table, especially the ones in columns 1, 2, and 13, and 15, 16, and 17. Those always have the same charge, and there's a rule for that. We've gone over. You should be able to write the formulas once you have the ions, because remember, the compound's formula should be neutral. There should be an equal number of positive charges as well as negative charges. Okay, so once you determine that ions um, in the compound, you should be able then to write a equation with a balanced charge to it. Naming ionic compounds is pretty easy. All you do is say the name of the cation and then the name of the anion. Quick reminder, a cation is an ion with a positive charge, any ion with a positive charge. An anion is any ion with a negative charge. Okay. Also, don't forget to use Roman numerals when you have a transition metal ion. And you have a list of polyatomic ions. Sometimes you will have polyatomic ions in your chemical formula. Okay, you should be able to do that with ionic compounds. If I give you the chemical formula of a compound, you should be able to give me its name, just cation, anion. And if you're given the name, you should be able to write the chemical formula for it. Okay. Then the other type of compound, molecular compounds. Um, you should be able to name the molecular compounds. This is the one where we use prefixes. Remember, because we could have a different number, different proportion of element to element in a molecular compound. So we need to use the prefixes to tell us how many of element 1 versus how many of element 2. Remember, in ionic compounds, there can only be one proportion between any two ions because it's fixed based on the charge on each ion. And you can only have one formula between any two ions. Here, you can have many formulas between any two elements that come in molecular compounds. And the last thing we talked about were acids. And acids can be broken up into two main categories: binary acids, which are made up of two different elements, and oxyacids, that these are acids that have oxygen in them. Usually that oxygen comes from a polyatomic ion. Essentially what an acid is a anion with a hydrogen a hydrogen ion added on there for each negative charge the acid has. Okay, so binary acids usually are hydrogen and some type of ion that ends in IDE. Just about all of the anions that end in IDE are monoatomic anions. They're made up of one atom. They're found in the right side of the periodic table on in columns 15, 16, and 17. And when the anion ends in "ide," you drop the "ide" and you stick the stem in between hydro and ic in this, and you call it a hydro whatever ic acid. Hydrochloric acid, hydrobromic acid, hydrosulfuric acid, hydrophosphoric acid, hydrobromic acid. When you have an oxyacid, the anion will end the ion's anion the acid's anion will end in ATE or ITE, ate or ite. When you make it an acid, the acids with an ate anion, you'll drop the ate and put ic acid in its place. The acids with an ite ion, you'll drop the ITE and put us acid in its place. Okay. One last thing I think I missed over here. You should be able to tell some of the basic property differences between ionic and molecular compounds. Things such as, I mean, we went over this in class on the last PowerPoint, but things such as ionic compounds come as crystal lattices, whereas molecular compounds form molecules. And ionic compounds tend to have higher melting points and boiling points because those crystal lattices are pretty strong. So to get those ions to separate from each other is kind of hard. Molecular compounds you can melt and boil a little bit easier because the covalent bonds hold the atoms within the molecule together, but the molecules are stuck together because of these things called intermolecular forces. We have not covered that yet. We will be covering that second semester, but they're not. The intermolecular forces are not as strong as ionic or covalent bonds. Ionic and covalent bonds are basically about as strong as each other, but the ionic bonds hold the whole crystal lattice together. Covalent bonds only hold the molecules together, and we have a different force, the intermolecular forces, that holds molecule to molecule in a sample of a solid or a gas. Okay.